Good morning, dear participants. On behalf of CIT family, I wish all of you a happy new year. So today we have three sessions. Session 1 will be handled by Mr. Bharat Kumar Alam of Extran Solutions. So his topic is Introduction to IoT and Use Cases and Demos. Session 2 will be handled by Mr. Kiran Kumar HM. Uh, he's from Mindtree, and he is going to address you on IoT industry overview. And the last session will be handled by Mr. Rajendra CJ, so who is research associated at CIT, so who won many national level awards with the student project. So he is going to demonstrate such IoT projects to all of you. So with this note, we will start the session 1. Let us take 2 minutes to know about Mr. Bharat. Let me take this opportunity to introduce Mr. Bharat Kumar Alam. Uh, he is principal engineer at Extran Solution Private Limited, Bangalore, from past 3 years. He brings 8 years of teaching experience as an assistant professor from various institutions of Telangana and Andhra Pradesh. He, ho- he holds MTech in Embedded Systems from Jawaharlal Nehru Technological University. His area of interest includes IoT hardware platforms, artificial intelligence, and machine learning. He is also hands-on on various IoT cloud platforms. He was part of successful IoT lab setup in Techno India University. Also, he plays a major role in establishing IoT Center of Excellence at various engineering colleges in Bangalore. He has conducted so many student workshops, FTPs, and corporate training for IoT freshers. So his area of interest include IoT, blockchain, and AI and ML. Such a wonderful personality and nice speaker, sir. Mr. Bharat sir, thank you for accepting our invitation and being part of this refresher program. So I request Bharat sir to take over the session.
Thank you, sir. Thank you for your warm introduction. And first of all, I wish you a very happy New Year for all the participants. This is the first. This is our first session in New Year. Okay. So before going to my introduction, let me share the screen here. Is my voice is clear?
It's crystal clear, sir.
Okay. Thank you. So let me share my screen here. Yeah, is my screen visible?
Yes, sir, it is visible.
Okay, right. So this today's morning session, like from 10 to 11:30, that I'm going to handle this particular session on introduction to IoT. Already you may have so much of introduction, but just I want to just brief introduction, like just 5 minutes, and after that we'll see some hardware platforms, like what are the related to the IoT, like what are the related to hardware platforms, and what are the different hardware protocols that we can use in this particular IoT, and lastly we'll see one or two demos based on this particular IoT. So after that, I think once you got some familiarity with this IoT, then later we'll connect this to blockchain. That may be my colleague, like Mr. Krishan. So he is going to have next two more sessions on how we can connect this IoT to the blockchain. So you are in a track, so don't worry about that. So first we'll see some introductions about the IoT, and then we'll see few demos. Along with this, here I want to give me a minute. So along with me, I have Dr. Monica with me. So she's a research associate from Extran Solutions Private Limited, and she's going to give one more demo for you along with my demo. So she's going to be give one more demo. Like we'll introduce her in the last half an hour, and in that particular time, will introduce her. Okay. I hope Dr. Monica is over here. Yes.
Yes, sir.
Okay.
I'm there.
Yeah. Thank you, Monica. Okay. So let's, without any further delay, so let's move on to the topic here. I hope what I'm understanding is that all the participants are from at least have everyone is new for IoT. I'm just thinking like that. Based on that only, I will explain the things over here. So this is the topic here. Introduction to IoT use cases, and as well as I will show one or two demos. So these are the topics that I want to perform manage in this particular session, like hardware platforms, hardware protocols, and I want to show you one vaccine tracking use case demo. So not exactly a complete implementation, but how we can implement using Raspberry Pi. So how we can try to achieve that vaccine tracking use case. So that use case demo that I'm going to show you in this particular session. And also we have a Thingspeak cloud demo is going to be available for you. So this is a definition of IoT, like most of you people might have seen from the last 2 days, or otherwise yesterday you might have gone through these particular definitions, and you already very well known about that. It is Internet of Things. So what exactly this Internet of Things is? That it is a self-configuring and adaptive system. So you know very well that it has to be take care of itself. The device, whenever it is installed, a device is installed in the IoT, means it should be self-configuring. It should be take care of itself, and also it should be adaptive to the different situations. Okay, so what exactly this is consisting of sensors. All the sensors we are going to used in this IoT, and objects. What yeah, I'm sorry.
Sorry, sir. That is from one of the participant. I muted him. You can continue, sir.
Okay, right. So we have the sensors and smart objects. So that whose purpose is to interconnect all the things. Like what are these smart objects here is nothing but your like whatever the things that you are using, Raspberry Pi, Arduino. So those are all comes under the smart objects, which will interconnect all the things. So things are nothing but all the original existing things which are connected with some sensors. For example, here car is a thing in the IoT. So how a car becomes a IoT thing? Because we are connecting so many sensors to the car, so that the car becomes a thing in the IoT. So like that, by connecting some controllers and sensors. So definitely there are three major things always available in the IoT: sensors, a smart object or controller, and we should have to have a third one is a cloud. So here the smart object will be connected through the gateway. So whenever, always remember that the smart object will be connected through the gateway. So all the sensors are connected to the smart object, and the smart object is connected through gateway to internet. And so from this internet we are able to connect to the cloud parts, all the cloud, whatever the different clouds we have. So we can connect all these sensors information to cloud. So simply speaking, Internet of Things will includes all these things. So here always remember that any device, anybody, anywhere, any business, any network, or any time. So all these things will comes under the Internet of Things. So there is no nothing is escape from the Internet of Things. Everything will becomes a part of Internet of Things. So like we can see today's world, all the applications, there are so many domains are there. All the domains are using the IoT, irrespective of discipline. Whatever it is industry, it is a human being, it is a even a human being also using so many sensors to measure his body parameters and all these things. So like that, everywhere Internet of Things is existing. What are the three basic principles of this Internet of Things over here? So first, Internet of Things means first we have to take one first principle here is the things that receive the data and act on it. Things that receive the data. So sometimes what happen here, there are some things which always receives the data only. So we have written a data reading program. We have written a data reading program so that it will always reads the information from the cloud. Okay, and according to the values, whatever that it is getting, it will act on to the outputs. It will act onto the outputs. Generally these are called actuators. So there is no, like, it is not going to receive any sensors information directly. They will get the information from the cloud. So here from the cloud to the device, directly we'll get the information from cloud to device, and according to the whatever the information we are getting from cloud to device, so that will be, that cloud to device information will be, it will act on some kind of actuators. So actuators may be door opening, door close, or otherwise it's a kind of all these things like printers, wearable devices, smart TVs, collecting. So all these things, okay, these are all comes under the things which are receive the data and act on it. And there is other category, that things that gather the information and send it. It will not do the receiving, it will do only sending. Things that gather the information means it will connect to all the sensors. So here other case is that here the controller will connect to the all the sensors and it will send the information to the cloud. It is not receiving any information from the cloud, it is only sending information to the cloud. That means it is the opposite case of first principle. First principle is that we are receiving the information from the cloud to the device. Second one is we are sending all the sensors information to the cloud. So here example, we are going to have motion sensors, moisture sensor, light sensors. So like that, different sensors that can be able to send the information to cloud. Coming to the third category, things that perform both functionalities. So there are the so many requirements which where we have to perform both the operations, like as we have to say, take the information from the sensor. Okay, we have to take the information from the sensor, at the same time we have to store the information on the cloud, as well as from the cloud, as soon as it is information is storing on the cloud, also we have to generate some alerts or we have to actuate some actuators. So all these three operations will be done on the single device. So that is also like these are the three things mostly happen in the IoT. Always read the information from the sensors, sending that information to the cloud, and acting on the different devices. So these three principles always consist in the IoT. So if you able to see this here, it is, this diagram will completely represent the IoT over here. Okay, we have so many value-added services in health, well-being, connected home, and smart city. So many things are going to be there. And here, data venue, like where we are going to store all the information over here. And here, distribution of the connected objects, so that we are going to get the information is distributed into different devices. And also here all the sensors which are connected over the system. So like that, it will represent both the things like sensors and as well as actuators. Okay, so these are the different domains where like we are going to see IoT regularly. Like you might have come across these things many times. Okay, so like in the consumers, hospitals and doctors, insurance companies, appliances provider, like facility management, retail stores. So like that, no, nothing is going to be escape from the IoT. Like in every domain we can able to implement the IoT over there. So there is a lot of scope for you to work on this particular IoT domain. So let's see here. Uh, if you want to build a simple IoT device, how it will be. So whenever you want to build any device, there should be some procedure that you have to follow, starting from the concept paper here. So what are the steps that generally we have to follow here is that whatever that you want to, for example, maybe today some projects are going to be introduced for you. So like what the projects will start from, they will first take some concept paper. Maybe generally in your case will take some IEEE paper as a reference to implement something, or otherwise you can get your own concept. Like no need to follow any IEEE paper, or otherwise you can create your own concept paper. Okay, so that concept paper was first we have to take. Next, from this particular concept paper, like okay, this is the things that I want to implement. So like that you have some idea over here. So once you got this idea, you can go for the block diagram implementation of that particular idea. So there you can implement all the things over here. And after that, generally you will go for the schematic. This is again a different part. If it is a hardware project, most probably IoT means we are going to have a hardware projects. So definitely whenever we are doing the hardware projects, means we should require a schematic over here, like the designs, like how exactly what are the sensors used, and how those sensors are connected to which pin of the controllers, something like that. All the pin details, like individual details of sensor and control connections will be represented over in the schematic. So once the schematic is ready, automatically the schematic will generate the bill of materials, like what are the sensors we used, and what is the like how many sensors and what are the quantity. Like for example, I used 5 resistors, 4 transistors. I used two temperature sensors, 3 LDR sensors. So something like that. Will generate a bill of material from the schematic diagram. So once all these things are uh, finished in the starting stage, then we'll have to go for implementation here. So this is fifth one. So fifth one will comes under the implementation part. So up to here we are just designed the schematic and all these things. So till now we didn't get the original components. So once we got ready with the bill of materials are ready, then we'll buy the materials from the outside, and then we'll start implementing the things over here. So what exactly here is that it is showing some sensors. Okay, so this is a DS18B, like it is a temperature sensor. Okay, this is a waterproof temperature sensor. That the photo that the image that you are seeing here is a waterproof temperature sensor. I will introduce this in our demo. Okay, and this is a Raspberry Pi 4 that I'm showing you, and we'll discuss about what are different hardwares that we are going to use in IoT. Okay, and we have a cloud over here, like we are going to write some API to connect it to the cloud, and finally we are going to display, like it may be a desktop, or it may be a mobile, or it may be a laptop, or whatever it is, but finally we have to display the things into some place. Like cloud is a storage, and the last one is a display. So we are going to have a display, like data display. So it may be in the form of graphs, it may be in the form of messages, or it may be anything. So like output display. Okay, so these four things that we have to follow. Like we have to connect all the sensors to the controller, and then we have to write the software code over here to connect to the cloud, and then finally we have to display the results. So this is one implementation stage. But once it is implemented, it is not finished over here. So we have to do some field testing. See, whenever we are doing some prototype means no one will believe you, like until unless you are going to do some field testing, whether whatever you implemented, whether it is working fine or not, that we are going to do some field testing over here. Okay, and after field testing, again we'll release some beta version, because always remember that whenever it is comes to usage, beta version means the people will use, and they will tell you that what are the bugs in your project. So like whenever it comes to use, we are going to know the original like what are the drawbacks of that particular project. So that particular drawbacks will be known to us whenever we release some beta versions. And after that, finally all the beta versions are successful, then finally it is entered into the production, and properly we'll document it. But always remember that this is very important one, release and documentation here. So whenever it comes to production, and we have to give all the details. Each and every minute details should be documented over here. So until and it is not documented, so for example, a sensor information, it should be very, very specific, like what the sensor, what is the voltage, what is the like all the specifications, and everything should be documented clearly, including with procedure and all. So then only your project will be complete. So these are the different steps: 1, 2, 3, 4, and this is the 5 is the implementation, and then 6 is the testing part. 6, 7, 8, 9. These are the testing and documentation. So these are the three different parts of any IoT project that we have to implement. So coming to this hardware platforms. So before going to this, I have a small question here. How many of you have come across Raspberry Pi and Arduino? Most of you people might be come across. How many of you have come across Arduino and Raspberry Pi? Most of you are might be come across. Okay, right. Okay, right. So let's see a few of them here. So you already known, so I don't want to take much time over here, but we have to introduce few things over here. Like one is Raspberry Pi 4. So you know very well that this is the latest board in the Raspberry Pi. You might have known very well about this particular thing. So here this is it's like a mini computer. Like you are going to have all the, sorry, let me put the slideshow. Okay, so you have all the things available over here, like these are HDMI ports. We are going to have two displays over here, and similarly this is our processor. Mainly this processor is a updated processor, like we are going to have a 1.4 gigahertz. Just I want to mention the capability of Raspberry Pi 1.4 gigahertz. So that means it is it's like a mini computer. It's not like exactly, but it is mini computer. And if you are able to see that this is a RAM size, the speciality of Raspberry Pi 4 is that it is giving a perpetual RAM. That means we can change this RAM like from 1 GB, 2 GB, 4 GB, and 8 GB. So it's a perpetual RAM. So here in this particular device, this is a 8 GB RAM. So this is a 8 GB RAM. So Raspberry Pi 4 will support up to 8 GB RAM. So it's more not it's not like not less than a mobile phone. Like it's like almost like your mobile phone, because today we are going to use all the 8 GB mobile phones. So it is a 8 GB Raspberry Pi 4. Okay. Similarly, we have some Wi-Fi chips over here. Wi-Fi chips over here. Some network connections like Ethernet support and all these things. All the chips are going to be available. And here we have a USB to connect all your keyboards and mouse, and here we have a Ethernet port, like to connect direct Ethernet internet connection, like Ethernet cable. Through that we can get the internet connection. And the specialty of this, along with this all these processor capabilities, we are going to have a GPIO pins. We have a 40 pins. Like out of this we can make use of 26 GPIO pins to connect different sensors. So like that, this particular Raspberry Pi 4 is I think sorry, and now I'm going to use this Raspberry Pi 4 for a particular demo. Okay, so these are the few details about Raspberry Pi 4. So so along with this Raspberry Pi 4, so we are going to have a one more board here. It is a one more well-known board in the IoT. Here it is an Arduino. Can anyone like here Raspberry Pi is already at most and a very advanced device, but still we are going to have a lot of use about with the Arduino. Can anyone differentiate that? Like, what is the advantage of Arduino over Raspberry Pi? So everyone can tell what is the advantage of Raspberry Pi over Arduino. Everyone knows, but what is the advantage of Arduino over Raspberry Pi? Anyone knows about that? What is the advantage of Arduino over Raspberry Pi? Any answer from anyone? Okay, it's cheaper. Okay, that is fine. That is a cost wise. That is also good. So one beautiful thing is about Arduino here is that it is having a lot of support for the different sensors, like various sensors, where your Raspberry Pi is also not compare with the Arduino, like not comparable with the Arduino, like millions, like it's like a very huge number of sensors supported by the Arduino. There are few sensors completely based on Arduino. They completely designed based on Arduino itself. Okay, so like that, because especially comes to healthcare things, like most of the healthcare sensors may not be supported by the this particular Raspberry Pi, but all the healthcare sensors, mostly all the healthcare sensors will be supported by the Arduino. Okay, right. You can add many sensors, like even Raspberry Pi also we can add many more sensors. Like it is because compared to the GPIO numbers, so Raspberry Pi have 26 GPIO, whereas our this Arduino is having uh, 14 plus 6. I think it is 20 GPIO pins. Like it is having some direct analog pins and digital pins. Okay, okay, right. We'll move back here. So that is a one like large support is available for the Arduino. So that's why still the people are using this Arduino to connect the sensors, and Raspberry Pi to connect the internet, and like it's used as a gateway. Most probably it will be used as a gateway, or otherwise it will be something like that. Wherever the sensors are not supported, then they can use this. I'm sorry. So they can use this particular so they can use this particular Arduino over there. Okay. So what the advantage over here is that it is having direct analog pins. So this is the one advantage of Arduino here is that it is having direct analog pins. That means if you have any analog sensors, you can directly take that sensors and connect over here. But that facility is not available for the Raspberry Pi here, because all the pins in the Raspberry Pi are digital. Those are GPIO. So if you want to connect any analog sensor, so you have to use some external ADC IC. Like you have to convert that analog to digital, something like that. You have to use some external ADC IC. Okay. And one more well-known board here is that Node MCU, where this is a simple like Wi-Fi is added for your Arduino. So like along with the Arduino, like Wi-Fi is also added over here, so that inbuilt Wi-Fi is available, so that all these things will be works with them along with the sensors. Directly we can have a Wi-Fi over here. But one of the disadvantages is that it is going to have only single analog pin. We have only A0. There are no multiple analog pins are not available. So for that, again we have to use some multiplexer to connect multiple number of analog sensors. See, just I want to just highlight what are the important things in a particular controller here. So Node MCU is having inbuilt Wi-Fi, inbuilt Bluetooth, so that these things will be used very well in the IoT applications. So, and I want to specially introduce one more board here is that no Nvidia. Anyone heard about this Nvidia? Just I want to know, anyone heard about this Nvidia? Yes, yes or no? At least one answer. Anyone heard about Nvidia? Yes or no? Or otherwise anyone works with Nvidia? Okay. For graphic support, like okay, you might have used in Nvidia graphic support. Okay, right. Yeah, gaming graphics card and all these things. Yes, Yes, it is exactly that company itself. Like that company, Nvidia, has developed a IoT board over here. Like it's not like exactly IoT, but it is a AI computer, IoT and a AI computer. So what the specialty here is that again, along with this, it is going to have a 4 GB RAM, along with a 128 core CPU. Like it is a um, very specially suited for the AI applications, and it is having a good graphics card. So that what happened here, along with the good RAM, like 4 GB RAM, and with good graphics connections, graphics card, which is available inbuilt in the Nvidia board, so that it is going to be available especially for IoT and AI applications. So because here you have all the GPIO pins available over here, you can see this, all the GPIO pins are available over here, so that we can connect all the sensors over here, so that we can implement the IoT applications. And at the same time we can connect USB camera or something like that, any other. And also internally we can implement so many AI programs, so that we can combine this IoT like sensors with AI, so that we'll get more real-time applications will be done on the Nvidia 4 GB AI computer. So we are working on this. So uh, if anyone have any help on this, we can help you a lot. Okay, so this Nvidia board, little bit, just I want to introduce, like it is going to use the Cortex A57 and 4 GB LPDDR4 memory, and 1.43 gigahertz clock speed, and it supports both the Bluetooth and the Ethernet connection. Okay, so only one disadvantage here is that from the Raspberry Pi here is that it doesn't support the Wi-Fi directly. So we have to insert some external Wi-Fi card over here. So whereas in your Raspberry Pi we have internal Wi-Fi, but here we have to support some dongle. Like we have to connect some Wi-Fi dongle, or otherwise we'll get some Wi-Fi chip. So that we have to insert inside this particular backside of this particular thing. Okay, so that is the only small disadvantage with the Nvidia board. But we can get so many dongles outside, so that we can connect and we can get the Wi-Fi connections, and it will be works similarly like your Raspberry Pi, and more than that, because it is having a 4 GB RAM and as well as good graphics card. So it can be a competitor for your Raspberry Pi. But thing is that again, the coming to the price wise, this is a little bit costlier. This is a little bit costlier compared to, like, almost it is double the rate of Raspberry Pi. Okay, but anyhow, whenever we have some advantage, means we have to bear a few things over here. So these are the different other boards that we can able to use: Arduino Nano on the ESP32. Here Uno plus Wi-Fi. You might have come across this Uno plus Wi-Fi boards. Okay, and this we are going to use something called MKR Wi-Fi 1010. So generally this is a tiny board which we can use very comfortably for the IoT applications, and because it is also have a direct battery connection over here. So if you observe this, you can directly connect your battery over here, and it is battery operated. Okay, it is battery operated. Of course it is having a power adapter also, but it is a mostly battery operated over here. Okay, and after that we can connect all the sensors over here, and this is very tiny board compared to the all other things. Of course Arduino is very tiny more than this, but it doesn't have any internal Wi-Fi. But whereas other three boards are having all the internal Wi-Fi, including with ESP32 and all. These are all having the internal Wi-Fi. Um, just give me 1 minute. Just give me 1 minute. I'm sorry for the disturbance. So when we are at home, I think these disturbances are going to be there. But anyhow, so with this, I want to stop the theory over here, and I want to take a demo right now. And after that, we'll see some details about the demo, like what are the things that I have used inside the demo, and what is the program, and all these details. We'll see a little bit in detail. Okay. So what is my demo over here? So you might have heard about vaccination in these days. Like we have to maintain the vaccination. So this is my like overall picture. Not exactly this is not exactly my demo, but this is some overall picture of my demo. Like whenever here vaccine is going to be manufacturing over here, and whenever it is manufactured, and it will be placed in a particular containers. So starting from containers, we should have to maintain a unique ID of each and every containers, and we have to maintain a unique ID of each and every vaccine, and then we have to use some storage, like storage temperature. We always maintain some temperatures over there. Okay, from the starting from here to ending, whenever this vaccination has to be finished. So from here to here, along with this long journey, they have to maintain all these things. Like they have to maintain the unique idea of all the containers and all the vaccines and everything, and they have to maintain some storage temperature over here. So, and these are all going to be tracked over the way. So like where the exactly the boxes are, like it may be tracking using the GPS. You know very well that device which we used for tracking is GPS. Okay. Similarly, to storage temperature, to maintain the storage temperature, like we have always use the temperature sensors to measure the temperature, and if the temperature is getting heat, the necessary actions will be taken care. So like that, so the vaccination should be tracked from the starting to ending, and at the same time it has to be calculate the temperatures over here. So that is the main funda in a vaccine tracking. Okay. So this is my demo that what I'm going to show you in a few minutes. Okay. So this is my Raspberry Pi 4 that I'm using here, Raspberry Pi 4 over here, to connect all these sensors here. And I'm using this DST22, so which I'm measuring, like I'm assuming that this is going to be used to measure the environment temperature. That means outside temperature of the containers, like what are the where the vaccine is generally stored inside a container, where it will maintain very low temperatures. Like it may be sometimes minus 20 degrees or minus 30 degrees. Otherwise, it is in the negatives, because that depends on the vaccine and those parameters. But we are not going deep into that. But thing is that we are using one sensor to measure the outside temperature, like what is the outside temperature of the this particular container. And second one is that we are going to use one more temperature sensor here. This is called DS18B20. So this DS18B20 will measure both negative and positive temperatures, so that it is very accurate in measuring. And this one more specialty of this is that it can be waterproof. So whenever you are measuring the very low temperatures, some sensors may damage, but this sensor is specially designed for that, so that it will measure all the very low temperatures up to minus 50 degrees. It can be able to measure. So this DS18B20, this particular sensor is going to be used to like measure the internal temperature of the container. So I'm using two temperature sensors. One is to measure the outside temperature, and one is to measure the inside temperature of a container, like box. Let us assume that this is completely a box. So inside a box, we are going to have all these things. So let us assume that this is a vaccination box. So inside this box, we connected all these things to that particular box. Okay. And I'm using one accelerometer to always maintain the position of the box in a right manner. Like generally, of course, in this particular demo, I'm not using this accelerometer, but I'm just telling like what is the use case of this accelerometer. What is the use case of this accelerometer here is that it will maintain the position, like box position. For example, here all the vaccines are here inside the box, and the vaccines position is like this. Okay, and it should be upside. For example, this is upside. While shifting or while moving from here to there, or while doing something like that, maybe the box position may be changed from here to here like this. So in such case, what happen here, the vaccines may get damaged, or this is not the right position to keep your box. Maybe I don't know exactly, but maybe this is not the right position to keep your box in a reverse direction. So in that particular case, we have to always measure the position of the box, whether the box is upside or downside. So this is going to be calculated through this particular accelerometer, so that it will always measure, and whenever the box is upside down, or whenever the box is in a reverse direction, it will give some alert through the buzzer. So that what happen, immediately will set the position of the boxes in a correct manner. So something like that, to track that position of that particular boxes, will use the accelerometer. And also this is optional, this air quality, like along with this vaccines internally, it has to be always measure what is the air quality of that particular container inside. So always, because sometimes that air quality also will affect the vaccine usage, sorry, vaccine effect. Okay. And also this always, all these vaccine boxes are like, let us assume that here I'm using a servo motor. Generally, but we can use any other motors to open your box. Like the box is automated, it's not like a simple key and we are going to open. So it is a motor controlled box, so that whenever you are showing a right ID proof over here, so this box is going to be secured through this particular card. So the respective person, the person who has this card, only can open that particular box. That means only some authorized person only can open that particular box. So that authorization that I'm using here, RFID card for authorization. So there are so many other ways are there, like mobile OTP, or so many other things are there. Like whenever we send a GP, we can use GSM over here, so that whenever we send a particular key to this particular GSM, that box will be open. So for open and close, I'm just demonstrating through the servo motor. Okay, and for security purpose, I'm using a RFID reader. So as soon as this box is delivered, so we have to always store the information that which box is delivered, and what is the, how many number of boxes are delivered properly, or otherwise used properly. So to all those information, to store all those information, I'm using a Thingspeak cloud over here. So like I'm just storing the how many boxes that are used, like box count I'm storing in the cloud, and as well as which box opened, because every box will have some particular ID. So this ID also I'm going to store it in the cloud. So like that, later we can track that how many boxes are used, and what are the boxes are used, and what are the boxes are left over. So like that, we have a good tracking of this particular vaccines. I hope you got that agenda of this demo. I think the concept of this demo, you got it. So let's see the demo. So for show you the demo, let's minimize this. Got it. I hope anyone can give answer, like you got the concept of that demo.
Yeah, I think
Okay, right, right.
I
Okay,
think
so
you're giving the demo on the
yes, COVID vaccine tracking.
COVID vaccine tracking. Okay, thank you. And is there any security models involved in this one?
Actually, I'm using RFID card over here. here, but most probably they will use some mobile OTP kind of security. So it's not like directly RFID they will not use. Generally, in original case, they will use QR codes. Like as soon as box is entered into the container, so every box will generate some unique QR code, and that unique QR code will be sent to respective officer. So that officer will receive that QR code, and the officer who has that QR code can only open that particular box. So in that way, they will maintain some QR codes.
Okay. Thank
Okay, right. So let me show you the demo before going to that. Let me show you the hardware part first. Okay. So after that, I will show the output, because output is a just 1 minute process. There is nothing is there in that. But just I want to show the hardware first. So for that particular purpose, let me switch on my camera. Let me switch on my camera here. So 108. 192. What happened to this? It is not sharing. Okay, I think I got some issue with the Android. I think it is asking some permission required to open the camera over here. But anyhow, mm, then how can I?
you. From the mobile, you can give the permission.
Okay, so I don't know. Right.
Just it's asking the permission from the mobile.
But but
Might
but
be.
but on my mobile, I didn't get any permission.
Uh, just if you scroll down the
Like, let me,
to
yeah.
record videos and save photos.
Okay, no problem. Anyhow, I think it is not supporting. I'm sorry. No problem. What are the sensors that I have shown in the block diagram? Almost all the sensors that I'm using over here. It's a very clumsy connections. Like all the things are having very clumsy connections. So I can do one thing here that. Uh, I will try this later, but anyhow, let me show you the program here. Okay, so at least from the program, I can explain what are the things that I have connected over there. Okay, so let me, for programming purpose, I should have to connect to the VNC viewer. So this is a one of the like SSH application. Like it is going to be some kind of remote connection to the Raspberry Pi over here. So I'm connecting my Raspberry Pi through VNC viewer. So like let us. This is my Raspberry Pi. Let us double click on this, and the default username and password for the uh, Raspberry Pi 4 is that Pi and Raspberry. So whatever the Raspberry it is, so the default user is Pi and the default password is Raspberry. You can see here it is Raspberry, RASPBERRY. Okay, so I'm just trying to log in here. So this is my Raspberry Pi screen over here. Okay, so let's.
Is this VNC is available built in with Raspberry Pi, or we have
Yes,
to install it separately?
It is built in, available in within the Raspberry Pi. So let me show you here. So, if you minimize this, like here,
Window, it's a window based, no?
yeah, it's a window based. Like here,
Oh,
you can
thanks.
see this VNC connection over here. So that first of all, we have to enable here. It is in the preferences. We have Raspberry Pi configuration. So here in the interfaces, we have to enable the VNC over here. That's it.
Okay, okay.
So once
SSH, SPL, IC. Okay, okay. Thank
these
you.
are all connections it will support, like SSH, like
Yeah.
putty kind of thing. That will also it will support, and VNC also it will support.
Okay.
So only thing is that we need to enable over here. Okay. So once I connected over here, so let me open my program here. I have vaccine control system. So let me explain few things in the program. Like I may not explain all the things in the program, but I will try to give most of the details about the program. Okay. So as I told you that I'm using here two DS18B 20 temperatures, like those temperature sensors that I have discussed with you, like these temperatures. So this DS18B20, I'm using two temperature sensors, making two boxes. Like I'm just assuming that one is in one box and other is in other box. So something like that. I'm just taking a two boxes as a prototype, and I'm measuring everything for these two boxes. Okay. So I'm taking two sensors, one each inside a particular box. I'm using this W1 therm sensor. This is the module, or otherwise this is the library to read the data from DS18B20. So that particular sensor, this is the library that we are going to use. And you know very well that Adafruit underscore DST. I'm assuming that you know something about Raspberry Pi. Okay, even though if you don't know, also just try to understand that these are all different libraries to access different sensors over here. So this DHT is a sensor, temperature sensor, which is going to use for measure the outside temperature. So outside temperature, only one sensor is fine, because for each container we have one. Sorry, for like for each vehicle we'll have only one outside temperature sensor, and whereas these inside means these are each container sensors. Container sensors means in temperature sensor, which will measure always container temperature, like whether it is maintaining the extremely low temperatures or not, because the vaccine cannot be withstand if the vaccine temperature is more than some certain range. Okay. So
Bharatkumar, sir, is it code is shareable?
yeah, it is shareable. I will share the code also.
Okay, thank you.
I will share the code also. Don't worry. Just giving the glimpse of the code. That's it. And I'm using RFID reader. So for that particular RFID reader, I'm using this MFRC 522 library. So to read the values from the RFID reader and all. And also I'm using like servo motor. So to it's like I'm assuming that it is a box opening and closing. So whenever you show the ID card, then only that it will open a like servo motor will be on and the box will be open. And similarly, I can use a buzzer whenever any wrong ID is used, or otherwise whenever any wrong position of the box is misplaced, like placed. So in such cases, we'll use a buzzer for alerting purpose. Okay. So these are all the some codes like related to the servo motor. So this is initialization of the servo motor. I'm initializing the buzzer, and I'm also initializing the servo pin and all these things. And here I'm initializing the RFID reader. And in my case, I'm using the Thingspeak. Like I think we are going to have one more demo after this related to the Thingspeak. I think that Dr. Monica will discuss about the Thingspeak. Okay, so I'm using the Thingspeak. This is the URL for to connect to the Thingspeak using MQTT protocol. Okay, mqtt.thingspeak.com. I have my inside the Thingspeak. I have my write API key. These are the some API keys which are inside the cloud. whenever you want to send your information to the cloud, we have to use this write API key and channel ID and topic. So these are the three things. These completely 5 things will be related to cloud. Okay, these 5 things will be related to the Thingspeak cloud. Okay, and I'm just trying to connect to the cloud over here using these 2 statements. I'm just connecting to the cloud, and I'm reading the values of humidity and temperature. So that is outside temperature. What is the outside temperature? So that I'm reading using this particular DHT sensor. Like just now I have shown to you here that using this particular DHT sensor, I'm able to read the outside temperature. Okay, so similarly here I'm reading all the internal container sensors, like what is the internal vaccine temperature. Like these are all the temperatures, like how many vaccines are how many vaccine boxes are there, that many temperatures will get. Here in this particular demo, I used 2 sensors. It's like 2 vaccine sensors. So those sensors will always measure the internal temperature of that particular box. Okay, of course here I'm not using any boxes, but just for information that I'm using, that we can place these sensors inside the box also. So that is the beauty of these particular sensors. Okay, actually we have to use a GPS tracker over here, like to track the position here, but unfortunately I don't have the GPS sensor with me. So I have taken some hardware, like has the box reached the destination. So whenever you say yes, then only it will ask for the correct ID card. Then only whenever you press yes, okay, the box is reached the destination. So whenever you press yes, then only it will ask for the ID card for you. But here you have to remember one thing, that this is a hard code right now, but here we'll use the GPS location. So if automatically whenever that particular box is related to particular place, so whenever it is reaches that particular place, automatically it will ask for the ID. So it will know by tracking the GPS location, it will know that where that box is presently. So we can always track that. So here instead of these particular statement, we have to use the GPS in the original application. But here I don't have the GPS sensor with me, so that's why I used a hard coded thing over here. So as soon as we are reading the ID, it will compare that whether these IDs are related to that box or not. It will give some box ID over here, and whenever ID is matched, then only this servo motor will run. It will open and close. Okay, and after automatically it will update the count to the count and as well as box ID. So here BID means box ID. Okay, it will both count and as well as box ID, both will be updated to the cloud. Okay, so again it will be repeated for the second box also, like that. How many boxes are there, the code will be repeated for that many boxes over here. Otherwise we can write a loop over here. Okay, that is our wish, like how we are going to write the code and all these things. But anyhow, so this is some small demo, like I can say it is a it's not completely implemented, but it is a very small demo. So let me execute this demo here. So let's save this and execute. So as soon as executed, so see here, it is measuring outside temperature is 24 degrees, and of course all the box inside temperature also it is measuring as 24. Why? Because I placed the sensors outside, but generally these 2 sensors will be placed inside the container. So where we have generally will have a negative temperatures. Okay, but here in my demo the sensors are outside, that's why it is giving both are same temperatures. See here, this is the idea of the box, first temperature sensor, and this is the idea of the second temperature sensor. Like that, different boxes will have a with a different temperature ID. So this is not box ID, it is a temperature ID. Like so, this is box 1 temperature ID, this is box 2 temperature ID, something like that. So whenever you press no means it's keep on measuring the things. Whenever you say no means just keep on measuring the outside temperature and inside temperature. Whenever you press yes, see here it is asking please access your RFID card to open the particular box. So here now I'm taking my RFID card here. I'm sorry, I'm not able to show you the video part here, but here I'm taking my RFID card here and I'm placing that RFID card near the, see here. You are listening some sound also, like box open and close, some servo meter sound also we are able to, I don't know whether you are able to listen or not, but here servo motor is running, like it is opening and closing. Why? Because here this ID is matched with the box. So whenever it is matched with the box, again it will goes for the second box, like whether you want to open the second box or not, something like that. So let us say yes here. And I'm taking other RFID card. See here, this time the RFID card is different. You can see this RFID card. This is a different card over here. This is the different card over here, and this is the different card over here. So like that, for different boxes, we'll use the different cards, so something like that, and we can secure everything, and we can keep tracking. If you are having a GPS sensor with you, if you are keep tracking that particular things over here. So like that, the box will not be open until unless you are not having a valid card. Okay, of course I written for the other also, but I don't have any other cards to check the invalidity. Both the cards I validated into the program. Okay, so this is the demo that whatever that I want to show you. So is there any doubts regarding this?
Yeah, at least a picture of that implementation, if you can show.
Okay. I will do one thing. I will switch on my video. Okay, like
Yeah.
laptop video, and I will try to show. Okay. So let me minimize this here.
You can log in onto your mobile also and
Okay, through mobile you want me log in here? Okay, just a minute. I will try it like that, in that way. So just a minute.
accelerometer is not programmed, I think.
Yeah,
Accelerometer and air quality is not
yeah,
programmed.
I don't have the accelerometer with me, so that's why I didn't program it. Actually, earlier I used accelerometer, but unfortunately I lost it. So in this particular demo, I didn't use the accelerometer.
And air quality is also not checked, I think.
Yeah, air quality I put it as an optional.
But actually, this is the gas, this one, no? Gas sensor.
No, it is MQ135.
MQ135 is a gas sensor, no?
No, it's not yeah, like gas sensor only, but it is a air quality sensor. Like it is
Yeah,
going to use.
because for agarbatti and other things like
No,
that.
that is different. That is different. That is MQ2.
Okay.
I hope.
Yeah, it's available. We have to pin it. Yeah. You can mute your my computer.
Yeah, just a minute. Just a minute. I'm sorry for the disturbance.
ಎಲ್ಲದು ಸೇರಿ ಇಂಗ್ಲಿಷ್ ಮಿಕ್ಕು ಸಿವಿಲ್ ಇದೆಲ್ಲ ಸೇರಿ ಅದೇ ಸರ್ಟಿಫಿಕೇಟ್ಸ್ ಒಂದು ಇಟ್ಕೊಂಡಿರ್ರಿ ಅಂತ ಮತ್ ನನ್ನ ಹತ್ರ ಬೇರೆ ಜೊತೆ ಕಳಿಸ್ಬಿಟ್ರೆ ಕಷ್ಟ ಅವ್ರು ಯಾರ ಕಳಿಸ್ತಾರಂತೆ.
Jyoti ma'am, unmute
Servo
ಆಗಿದೆ
motor. Oh, we are interested in that servo motor. If you can show that servo motor opening and closing.
Are you able to see the video?
Yeah. Oh, we are able to see that. Can you show that servo motor operations?
I'm sorry, I'm not able to handle both camera and this. Are you able to see this?
Yeah, if you are able to show us that servo motor and opening of that box, I think it will be.
Like you want me to show the running?
Yeah. How that actually servo motor and it is coupled.
You mean your connection part or otherwise? Connection part or coding part?
Yeah, this is okay. Actually, how that servo motor and how that opening is going to take place.
Yeah, I'm sorry. I'm sorry. Just a minute. Yeah, I think I'm getting some disturbance. Can you please mute it? Yeah, can you please mute it? Susmita. Madam Susmita. Okay. Sir, I think I can show you the code, but the code part I can show you, but I think it's really difficult to manage that.
Yeah. It's okay, sir. Because we wanted to see that servo motor how you are coupled it the this one.
To Raspberry Pi.
Actually, we wanted to see that how actually it is opening. What is the mechanism you have used for opening?
No, sir. Actually, here what exactly I used is only connected open that one. So I'm just uh, rotating for 90 degrees. Like from see here, you can see if this 12.5 to 2.5. These are some numbers. So it will be rotate from 2.5 to 12.5 means it will open that one. So generally we'll adjust inside the lock. We have a the rotation should require to open the lock and close the lock, something like that.
Okay. No problem. No problem. It's okay.
Just I'm showing that. If you have, if you want, I can share this and we can discuss of the session. I will provide my all my details so that we can discuss of the session. Okay.
Yes, sir. Yes, sir. We can do that.
Yeah,
Sure.
I'm sorry. Without any delay, I want to hand over the session to my research associate, Dr. Monica. So, Dr. Monica, are you available?
Yes, sir.
Okay. So we have a one more small demo on the Thingspeak. So Dr. Monica will show that small demo on the Thingspeak. So Monica, you can take the session. So let me close this and let me. Yeah, I'm stop presenting here. Sir Anil Kumar sir, are you there?
Any help needed, sir? This is Jyoti.
Yeah, yes, madam. Can you give permission to Monica? Yeah, okay, right.
Yeah. Yes, sir. 1 minute.
I think already she got.
Yeah. 1 minute. Sir.
Okay.
Yeah.
Very good morning, all, and happy New Year. My name is Dr. Monica. I think there is a sound. Okay. My name is Dr. Monica, and in this session, I'm going to demonstrate how the things or how the data should be
Madam,
connected
I
to.
request, can you please mute all other people, madam? Can you mute all other people? Like, because there is some kind of disturbance.
Okay.
It is from my side. No, it is not from my side. Some
So,
kind of this is coming. Okay, okay, no problem. Monica, you can continue.
okay, sir. Okay. Thank you. So, in this demonstration, I'm going to tell you how to connect your data, capture the data to the cloud, and then how can we download the same data from the cloud, from the Thingspeak. Right, this is the particular libraries that we have to import for the capturing the data. MQTT for the connection purpose we have to import that library also. And we are using pin number 4 for that, for the DTH sensor. And these are the particular port devices, SPI port and SPI devices for connecting our port to the memory. We have to set up these configurations also. And in the next part, uh, for that connection to the you know for taking the capture data properly, we have to specify something like MCP for the capturing the data from the gas and moisture sensor. So for that we have to specify the port number and the device here. To connect the cloud, we have to specify the server address. So we are here using the this MQTT with the MQTT protocol. We are using the Thingspeak cloud, and port number we are using here 1833. And this is the particular write key and channel ID. I will show you what that means soon. And for that there is another parameter like a topic. Topic tells us what is the channel and from where we have to send our data. This is the particular code. For that we have to
Madam, are you sharing the screen? Yeah.
it's I think it's I have already showed her.
Yeah, yeah, shared, ma'am, shared, already shared.
Okay, okay. I have to write down the channel ID. That can be dynamic, or we have to create more channels, and that channel ID can be specified here. And for the public, for the data to be sent to the cloud, we want some write API key. There are two types of API keys, one for the write and one for the read. For the cloud purpose, write key will tell us that we have some data to publish to the cloud. Okay, and next we have to make a connection for that. So we are creating a client, instance there. And for that after creating the instances, we have to connect that instance to the server. So this portion of the code help us to we have to specify there what is the server address, as we have specified the and things speak with the MQTT, and in which port we are connecting there. Okay, now in the next we have to capture the data from the sensors. So for the DTH, we are capturing the humidity and temperature. We have to specify the sensor and pin number there. And for the moisture and gas sensor, we have to use this read.adc. ADC means analog to digital converter. We are using here pin number 0 for the moisture, and the same pin number 0 for the gas sensor. And this capturing I have done in the looping part. First it will display the values of all four parameters, and after displaying the data, what we are going to do, we have to capture the data and send it to the cloud. Okay. Let me show you the interface of the Thingspeak. I think the interface is visible to all.
Yes.
Yes.
Yes. Okay. Though this is the Thingspeak, I am going to create a new channel here. Already it is done is in this part, but I let me show you the from the scratch. This is the name of the main channel that we have to demo one. I am just taking a name, a simple description that is optional. Also, you can make a simple description of the particular project, just measuring the data. And field number one, the what type of data we are capturing, this field 1, 1, 2, 3, 4, 5, 6. We have to remember for what type of data we are using the fields. Just like for the first, I am using the temperature. So uh, this is for temperature, and then for each sensor we have to create the individual field there. I'm using four types of sensor: temperature, humidity, gas, and moisture. So we have to create four field here. Next will be the humidity, and next will be the moisture, and this is for the gas. Right now, you have to save your channel. As you can see, four fields have been created, but no values because I didn't run the code. But to go to the code part, let's understand some things this is the particular channel ID through which we have to make a connection to the IoT sensor to the cloud, because we have lot of channels there. So for the unique purpose to which channel I'm sending the data, I have to specify its ID there. And for the setting, this is our setting, and yeah. These are the particular write API keys and read API keys that we will use in our code. Write API key we have to copy paste, or we have to remember this key for the writing purpose or the sending data to the cloud, or if you want to access the data in our particular mobile or in our system, we have to use these particular key, right? So uh, all these things that just a channel ID and API keys we are using in our code. So go to the code here. So okay, let me. I will change later. So from publishing the data to the cloud, what we have to send, it has two parameter, like what is the topic. Topic will contain the what type of data, or you can say the what is the channel ID and what is the right API, means the configurations of the cloud we have to send. And the second part is the data part. It will contain the what or the data, particularly it will describe the data only. So we have to create a data variable, and we are storing here the values, in the field one we have to remember the things field one we have to create for temperature, or field 2 I have to create it for humidity, because if I misplace this, then the values will be get misplaced. There is no issue regarding the values, but it will create confusion if I will put it humidity in first column and the second column the temperature. So for the if I will get the data, and the or headings or the some misconception will be there. Okay, so I have to write in this particular sequence field 3 for the moisture and field 4 for the, okay. And this is the particular client we have to publish the data and cloud. And the configuration we have to make there, just go here, like what is the channel ID, and I'm to make a changes. Go to the our Thingspeak, and I have to copy that part also. Yes, and because
Madam,
yes, sir.
do you have your mobile nearby? That voice, we are getting that voice. I think because of some mobile signal.
Yeah, yeah, just
Otherwise, I think it is sound of
okay,
earphones.
okay, okay. Is that okay, sir?
Yeah, okay, continue.
Okay, okay. So for the just a minute, channel ID. No? Okay, I have pasted in the sorry that right API key part, and we have to here for the writing purpose or the uploading the data we are using the write API key. Okay, and we are pasting it over here. Sorry, it's not copied properly. I think. Okay. Yeah, so this is the particular code is ready for the publishing the data only. So let me save the data and execute the code. Yeah, as you can see, this is the particular values here, and I am taken the time for the 2 seconds. So after 2 seconds it will go to uh, publish to the cloud directly, as we can see in here, the view. These are the particular values, and it will keep updating uh, timely.
Madam, Monica, madam,
Yes, sir.
why always we get the lines in a fixed thing like red lines we are getting, no? Because I have
Yes.
also seen many outputs which are just constant.
Sir, constant values because my time interval is less. These you are particular asking for these lines, or
Yes, yes, yes.
these are the for the time interval being a key, for these to these times I'm getting these type of data, like
Yeah. Do you have any previous experiment results where we have the variations in the time, humidity, gas?
yeah, 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 yeah,
Yeah, you can show other chart.
yeah, just like demo purpose. These are the particular variations you can see. For the moisture sensor, it was not dipped there. Here you can see the like these are the variations in particular humidity and gas. It was very dry, so it was giving the 103 values.
Uh, do we have any provision to define the y-axis here, like scale what they have used? Most of the time we will not understand that scale.
No, sir. Actually, it's a dynamic scale. So
Okay.
based on the values, it will be graph will be moves closer. So
Yeah,
it's a
because
dynamic
that
value.
value itself is getting means sometimes it will be thousand, sometimes it will be hundreds.
Yeah, yeah. Then in that case, that's what it is based on the values. It will automatically adjust its scale on the y-axis. So y-axis is not in our control.
Yeah.
So
Because it's showing something like temperature 18,
yes, yes,
16. Was is it a degrees Fahrenheit?
yeah. It is actually in the degree centigrade.
Yeah, and moisture also 1023. Um,
Yeah,
what
moisture.
actually what?
Actually, in the moisture, we have two values. Like 1023 indicates complete dryness. Like that is nothing but the particular soil is completely dry. So whenever we keep this moisture sensor inside the soil, so it will then take the moisture value so that it will be down to zero. So the minimum value is zero and the maximum value is 1023. So
But sir, is it meaning that we have the data in the digital data and that digital data is converted into decimal values like this? 8
uh,
bits or 4 bits or 3 bits?
no, no, actually these are the directly values read from the sensor. Okay.
That's what in digital form the data are read or because 1024 means 8 bits is required to define 1024,
Yeah, yeah.
something like that, 0 to 2024 for here
Yeah.
gas.
So those values are there. Maybe the sensor is giving the digital value, but in the program we are going simply converting that into decimal values, so that all the things, all the outputs are decimal over here. Right?
I think these values are not in our control. It's directly from the cloud. It has got that values.
No, no. These are the values which are getting from the sensors.
That's what. From the sensors, they are getting some values,
Yes,
and in the cloud, they are making this conversion and showing the numbers like for temperature 16 to 18, for
yes, yes.
humidity 85 to 90. So
Exactly.
this conversion, I think it is not in our control.
Yeah, that conversion is not in our control because that will be depends on those values. It will automatically convert its scale.
Okay, and can we get that meaning of these values? Because most of the experiments we are also conducting here, and we are
Okay.
not getting the idea like what is the meaning of these values.
Yeah, okay. Let me explain, sir. Here, if you are able to see in the screen, the first one here is the temperature in degree centigrade. Okay.
Hmm.
So generally, this what is the temperature sensor used in this particular demo is to calculate the environment temperature and humidity.
Okay.
Okay. So within the, for example, if you are placed that in a room, and you want to always measure that particular room's temperature and humidity. So
Yeah.
these
Not
two,
normally, if you just see the normal temperature of the room,
yeah.
we are not at all staying in 18 degrees.
No, no. Actually, this is I think Monica. You are from.
North India.
Yeah,
Yeah,
she's from
not
North India.
anyway. In India, we don't have the temperature of 18 degrees.
No, I
Only
Yeah,
think
air condition and that too very low air condition.
no, no. I think it is the original temperature sensor, sir.
yes, sir.
It's original value. It's not. That is the original temperature that.
Interestingly, on
Yeah,
1st January it was 18 degrees, and yeah, 1st January it has been shown. And as the time goes on, the temperature is decreasing. The
yeah. Maybe depending on that particular area. So
no, the point is because I was also getting confused with these graph. As the time goes on increasing, the temperature is decreasing. Actually, the temperature has to raise if it is of morning or in case of evening also this will be not normally the temperature. Even our air condition will also support up to 20 degrees or 22 degrees
okay.
air
Um,
condition, and that too very chilled air condition.
No, sir. No, exactly. This whatever the temperature sensor that we are using, it may be having plus or minus 2 degrees difference, but not exactly completely different difference. So it is the original value.
That variations we are observing means if the temperature goes on increasing or decreasing,
See
but
that. Uh,
corresponding to these values like
okay.
16, 18, 16 degrees centigrade, very rare case.
Monica, when you have tried these values, like last night or
Last night, sir. Currently, it's. I will show to you the current values. Here is the current values. Like temperature is 16 here.
see
uh,
presently also it is 16
yeah, yeah.
degrees.
What is the meaning of this 16? Because right now the temperature is not that low, no? Degree
Here,
centigrade, if you can
here
say.
is low, sir. Here is low.
In
It's
her place,
okay.
no, in her
16
place.
degrees means I think it's very, very, very cold. Even air
Yeah,
condition. AC will also not set up that temperature.
No, sir, it will be possible. In the north areas, even I faced in my personal, I faced that particular temperatures in the north side.
Okay.
Yeah, yeah. You can feel like that is a very common temperature in the January in the north side.
Yeah, we are
Yeah.
very close to Kashmir now, so the temperature is very
These are
low.
all original values, sir. There is no doubt in that.
Oh, no, no, I am not doubting that one.
Yeah.
The experiment is conducted, you are getting some value, but I am feeling what is the meaning of these values, or what is the meaning of these values when we are taking some readings and things. Because 92 humidity,
Yeah.
what it means to us.
Yeah.
Always, if you see the old results also, you will
Yes.
get the same curve.
No, no. Actually, within the 1 hour, generally the temperature will not change much. So whenever you measure for a complete day, for example, if you make the time slot as every 1 hour, so then you will see exact difference. Like Monica, do you have that time series channel? Time series one? Yeah, see, you can see these. Actually, these are the some values measured in the uh, like time series. Like from morning, every 1 hour, like
16.
every 1 hour, we are going to measure some values, something like that. So,
Yeah.
so it is slowly, it is changing. Sometimes it is changing very high, and sometimes it is changing slowly. Like it is depending on that particular situation. Like sometimes people are moving around that particular thing, and sometimes no one is going to be around the temperature sensor. So it's like a
No, variations is okay. Point is, because I have also tested with the Thingspeak with pulse rate.
okay,
It's
okay,
showing some curve, but when we are digging the things, why it is showing in that way, very hard to digest. That's why actually I asked the question.
okay, okay, okay. Anyhow, sir, we'll discuss that. What are the things that are behind that particular thing?
Yeah,
Okay.
yeah,
We'll discuss about that.
yeah.
So, Monica, with this, will
Excuse me, Bharat sir.
yes, sir.
You have still more slides?
Yeah, no, sir. It's fine.
You are done now. It's
Yeah, I'm done.
QA
I'm done.
session.
Yeah, I'm done.
Okay, except the participants who have a question and answers to ask, rest of them take a break. So at 11:45 sharp, the next meeting link will start.
Yeah.
Sorry, next
Thank you, sir.
session.
If any participants have any questions, they can post your questions here. I will be there here for more 15 minutes. So I will answer your questions from the chat box.
And Bharat sir and ma'am, Monica ma'am, thank you very much. That was very much resourceful. So practical oriented, always interesting. So many, because only with slides we won't get that much. So practical implication we really understood well. So thank you very much for your support and your resourceful address. So
Thank you.
participants, if you have any questions, please post it to, or else directly can interact with Bharat sir. So 11:45 sharp, the next session will start. Thank you. And even attendance link is posted in the chat. Those who want to mark their attendance, please mark.
Yeah, here I provided my email ID, so you can make a note of email ID so that if you have any queries in regarding the any implementation of any projects, you can discuss over through this particular mail.
I think no more questions. Even I'm not seeing anything in the chat window. Thank you, Bharat sir and Monica ma'am, for your time for us.
Thank you, sir. Thank you very much.